All right, guys, what we're going to be working on today is, you can see from all this green that we've got yet another refrigerant leak on this system. This is a 6.5 liter diesel on a 99 Suburban. So it's leaking out of the high pressure valve here, as far as I can tell, because it's clean under the cap, but it's coming out all under the cap and shooting down into this area here. If I take this cap off on the low pressure side, it's also leaking here. Now, I've tried spritzing these by putting a gauge set on them. You know, sometimes the springs get stuck. I've cleaned this up and it's just come right back. This is what it looks like after about a week or so, week and a half of driving. Now, the low pressure Schrader valve we could change without evacuating the refrigerant charge, but the high pressure one is a ball valve design, and the only way to change this out, it's a special socket, and we're going to have to evacuate the refrigerant in order to pull it and replace it, unfortunately. So that is what we're going to be doing here to deal with this problem. So I'm going to clean this up so that we can get a better look at everything, and then we'll come back. All right, guys, I got these two couplers cleaned off of the die as best I could here. I mean, it's really, you know, some places where you can't get it off at all. Like, it stained the label down here, and I just can't get that off. But I got it off around here. And the main thing is to get it off around these so that when we put this back together and do the repair, we'll know whether it's leaking again or not. Now, the deal with these two is you got to pull the refrigerant out of the system to change the high side port. And the reason for that is it's not a Schrader type valve, it's a ball valve. So there's no way to replace it while the system's charged. The low side port over here, which it was also leaking a little bit, so I'm going to end up changing them both. You can sometimes get away with one of these kind of tools that goes in there and pulls the thing out. But I have really, and there's like a magnetic tip on the end to hold the valve, but I've never had any luck with this type of tool when the port is horizontal like this. It works better when it's a Schrader valve type port that's vertical, because what ends up happening is you end up getting the valve, and as you pull it in here, invariably the gravity is working against you, and just like you can see in the bore of the barrel here, it'll grab the valve and pull it off the thing as you try to pull it out. So since I have to evacuate the system anyway to change the high, I'm just going to change them both that way. It's a lot easier, and I'll show both. But I mentioned this just in case you have that tool, you can give it a shot. Now, the actual parts, I'll go ahead and tell you the parts here. Here's our high side. So it's just a complete assembly with an O-ring that unscrews from here. And there's a special tool that you need to grab this. It's not a regular socket. I'll show that when we get to the point of actually removing it. But this guy is an AC Delco 15-5438. And that's a General Motors number 52458184 for the high side on these old body style trucks and some other vehicles as well. Now, the low side, like I said, is a Schrader valve, and you can see that guy in there. It's just not totally different technology-wise than what's in your tire. Of course, it's not the same one. And this guy is an AC Delco 15-1119 or a General Motors number 3041827. So these parts are both still made. Right now, you can buy them brand new. I'll put a link down in the description where you can get them. So, and these are the two things we're going to actually change, this whole assembly and then just the valve that's in here. Now, like I said, in order to do this repair, you've got to have the system evacuated. Now, maybe you do this repair because it's a good time because you were changing the compressor already or you had a leak or something else. But in my case, I don't have any of those other things, so I'm actually going to have to evacuate it out. Now, I'm going to be using a machine I have for this, and I'm not necessarily going to show all of this in this video, but it hooks up like a gauge set, and you can use this to evacuate safely without, you know, hurting the atmosphere, all of the R134 that's in there. If you're interested in how something like this works, I'll put a link up in the top that you can check it out. But I'm going to run the machine, I'm going to suck all this stuff out, and when it's all empty, we're going to come back and do the repair. All right, guys, we've gotten this system evacuated, gotten all of the refrigerant pulled out of it. So at this point, we're ready to begin the repair. So first thing we're going to do is we're going to take a tool like this, which is what we're going to use to remove the valve that's on this side. And we're we're just going to unscrew it just like you would from a bicycle tire or a vehicle tire. Of course, I lost my alignment in there. All right, guys, sorry I had to cut that, but this ended up being a real PETA. And I finally got this guy to come out. But what you can see is the reason for our leak here is this guy's broken. So the problem I had was, I kept turning it, but it wasn't coming out. And the reason was it had separated from this. And so luckily, the tip of this little valve was enough to get in here with a pair of pliers and pull this guy out. So otherwise it could have been a really, really bad day. But it's always a good idea to compare your original with your replacement just to make sure, other than the damage, that it looks the same, and it does. So we're going to go ahead and open up this little container so that we can put the new one in. And we'll see if we can do that without dropping it. All right. Now with that problem fixed, it should go in really well. And just go 2-finger snug, and that's it. So if we didn't have that problem, if I can go in here and find the ridge again, we should have been able to just quickly change this guy out. It shouldn't have been any big deal at all. You can see he's right there at the edge. And you can get him out. But because that guy was broken, it turned out to be a big hassle. All right, well, you never know. Like, the simplest jobs can quickly go south on you. So you just have to be prepared for that. All right, so I'm just going to, again, put this guy back in, 2-finger tight, and we'll go ahead and put our cap back on. That one's done. Now the high side. So for the high side, I told you before, you need a special socket to get it off. I got one of these Master Cool 98 234s. And the way that guy works is, you can see there's a kind of a hexagonal top on this guy. And that just comes right off just like that. I suspect what we had too is a problem with the O-ring on this, as well as this little ball valve. But you can see inside here now, there's that little ball valve that controls this. And there's the other side of it. All right, so we're going to replace that with our new part we gave earlier. And then before we actually screw it in, I'm going to take just a little bit of refrigerant oil, just a little bit of it right along the O-ring. And I'm not like pouring a lot on here, I'm just using the tip of the cover to spread it around evenly, just so we don't put any stress on that O-ring as we put this guy in. Tighten down with your finger first. And then put the socket on. Now, I could not locate a torque value in the service manual for this guy. So I'm just making sure he's snug. If I end up finding a torque value somewhere else, I'll roll it at the bottom. But I think what they really intended you to do at GM was just replace the entire assembly here with the brand new piece. All right, at this point, what we're ready to do next is get a gauge set out, and we're going to pull a vacuum on the system, and we're going to make sure that we can hold a vacuum, and that'll confirm that we no longer have any other leaks besides this one with the two valves here. So I'll go ahead and show you that. Basically, the repair is done, but I'll go ahead and show you pulling a vacuum on it and doing that test. What you would do after that is go down the path of recharging the system based on whatever was specified on the sticker on the top of the accumulator. And this particular system is a Suburban, so it takes 3 pounds of refrigerant, but different trucks take different amounts, so you always want to look at that sticker. If you get an AC Delco accumulator, it always has a sticker to put on the top there to give you that kind of information. So we'll come back after I get the gauge set up. All right, guys, this is just my, handy dandy Harbor Freight gauge set. Nothing special. Just going to get our high and low side couplers installed. Get some of that tension out of that line. All right, and then so we're going to end up having the center line here just going to a vacuum pump, and we'll come back up and look at this gauge later, but we're going to be pulling it down here into the vacuum area. So here the yellow line's hooked up to our vacuum pump. We're going to go ahead and fire this guy up. Open up this valve here, and then we're going to slowly open up our low side and our high side. And we're going to watch this gauge go down as it vacuums out. Now, it's only going to take a few seconds because we had already evacuated this particular vehicle. We already had a vacuum on it. We lost the vacuum when we replaced the valve, so we're just pulling another vacuum on it. And the reason you pull a vacuum on this is to retrieve any of the atmospheric moisture that may have gotten into the system. Water vapor is the enemy of your air conditioning system. By pulling a vacuum, we're going to force all of that water vapor back out of the system. Keep it nice and dry before we put additional refrigerant and pag oil back in it to recharge it. So basically, on a step like this, anytime you do a repair on the air conditioning system, after you're done, you want to pull a vacuum on it. You want to take it down as low as it'll go, which is typically on the gauge set here. This is as low as this guy's going to read. And then you're going to let it sit for 15, 20 minutes. You're going to check it to make sure that you're holding. All right, guys, so actually it's been 30 minutes, and we're still at 30. We haven't lost a drop. So this was just the first test, though, right? So we've got both these valves open on the manifold. We've got both the valves open on the coupler. All this test has done for us is confirm there's no other leaks. Whenever you change the service valves, you got to do an extra test, right? Because at this point, these valves are open, so we don't know if the valves themselves, the replacements, are defective. So the first thing we're going to do to validate that is we're going to go ahead and close this coupler on the high side and remove him. Okay, and you come up here, you can see we're still holding the vacuum on the low side, and it's still going to show a vacuum on the high side because even though this is open, this is closed. And so there's still a vacuum in this hose. So what we're really looking for here is we're looking to watch for another 15 minutes to see if we have any gross leaks on the low side. And what that's going to do, it's going to tell us, is this ball valve holding, so that we know the part we put in here is not defective. After that 15 minutes, we're going to put this coupler back on, and then we're going to reopen him, and then we're going to close this guy and take him off and do the same thing to make sure that new Schrader valve is good. Now, some of you might say, well, you know, what about any captive air, right? So when you put this coupler on that valve and you have this closed, we know that we have a vacuum all the way through and up into here. Yeah, there's going to be a tiny bit of atmospheric air right at the very top of this guy and right inside between the threads and the ball valve here, or even between the threads and the beginning of the Schrader valve there. But that's okay, because even after we do this step, 15 minutes to check for leaks on this valve, and if you only change this one, you would be done, but we change both. And then flipping in 15 minutes on this valve, we're going to end up hooking all of this back up again, and we're going to end up having to pull a deep vacuum, right? These vacuums were just to check for leaks and get atmospheric air out, but mostly to check for leaks. After those tests are done, we're going to end up pulling a vacuum for 1 hour, and then we're going to let it sit for 30 minutes. And at that point, we're ready to recharge the system. So I know it sounds like a lot of work, but you got to do it right. So if you're not going to do it right, don't even do it at all. So at that point, you'll be ready to recharge the system. I hope this has helped you out. If you learned something, if you found this useful, how about giving us a like here on this? And if you had any questions or something I didn't cover, go ahead and leave a comment below. Otherwise, like I said, thanks for watching, and please consider subscribing.